Okay, back. I guess that's my first video. So I'm going to start where I started on the last video, because this was a real surprise to me that I could actually break up these groups. And remember in that last video, my first video, where I said I broke this up into 3s and 2s. I took the last digit of the first 60 Fibonacci numbers, which do repeat over and over. So like the 61st number is the same as the first number, and the 62nd number is going to end with 1, and the 63rd number is going to end with 2, and the 64th number is going to end with 3, and so on and so forth until you get to the 120th number, and then it's going to start over again. You can check that out for yourself. And then I think it's at the 300 mark, the last 2 digits start repeating. And I haven't even got there yet. I'm still working on the 60 wheel. I've also, I have a lot to share about what's called the D circle of the first 24. But that'll be and that's actually where the 369 really comes into play, is in the D circle of the first 24 Fibonacci numbers. But we're not going to talk about that in this video. That'll be another video. I wanted to go back to this because this was a surprise to me, and it's like the way this thing has been working. It's turned into the Fibonacci circle, Fibonacci sequence, excuse me, has turned into the biggest magic square, magic puzzle that I've ever ran across. It's doing math in so many different ways. Almost every geometric shape I've explored is doing math. But remember in the last video where I said, when I broke this up, and then I said, oh, these are groups of 2 and 3. They're doing this math, 4 plus 2 equals 6, 2 plus 6 equals 8, 1 plus 3 equals 4, 3 plus 4 equals 7. They're doing math continuously, even when you break it up. But I broke it up in sets of prime numbers, 3s and 2s. And I remember I said, hey, that gave me another idea. So let's talk about prime numbers, because the Fibonacci, this Fibonacci sequence has a lot to do with prime numbers. And I'm not a mathematician. I would call myself, I see patterns. I do not have, I'm 66 years old, and I'm looking into going to college now, but I never did make it to college. And now I'm obviously interested in mathematics and pursuing a degree, because the Fibonacci sequence has revealed itself to me. And that's why we call this decoding Fibonacci, or Fibonacci decoded. The Lucas sequence is just as profound, and what's called Fibonacci sequences are just as profound. It seems like numbers are arranging themselves in mathematical proportions, and they're doing math. Let's talk about prime numbers. Where do prime numbers pop up in the Fibonacci sequence? Oh, but first, let's talk about my claim that all the geometries I've looked at are doing math. Here's an example, the Star of Solomon. This is again the last digit of the first 60 Fibonacci numbers. No matter where you take the Star of Solomon and click it, and it's, again, I get the wording all wrong. This is a pent. If it's got points, it's a gram. If it's got sides, it's a gon. So if this was like that, it would be a pente, which is 5, gon, and gon is sides. If it has points, it's a gram. So this is and actually, since you can do this with one line, this is actually a unicursal pentagram, because you can do it without taking your finger off. You can, do a whole thing. Anytime you can make the whole shape. Cursal is cursive. Remember how we were taught to write without taking our pen off the paper? That's what all this is. Uni, one line, cursive, one line, pente, 5 gram points. Okay. Every shape seems to be doing math. This is an odd one. It's adding by 2, adding by 6, adding by 8, adding by 4, depending on direction of rotation. So let's figure it out. Let's go from this point to this point. Well, that looks like an add by 2 pattern, doesn't it? 2 to 4. Yeah, 2 plus 2 is 4. So let's say that's an add by 2 pattern. So let's keep going. 4 plus 2 is what? It's 6, right? Let's get a pencil, right? 6 plus 2 is going to be what? 8, right? 8 plus 2 is going to be what? 10. Drop that, but this is in base 10, so we drop the 10 column and we get the 0. 0 plus 2 is going to be what? 2. Right back where you started. This is going to change. I did this so I tried to color code it so we could, you know, let's start where we did before and try to figure this out. So now if we take this Star of Solomon that's underneath here, this orange one, and go from the 3 to the 9, what is that? 3 to 9. That looks like an add by 6 pattern, right? So let's do that. 3 plus 6 is 9. And then if we're following kind of parallel this line, but we're going to come out here, 9 plus 6 is what? It's 15, but drop the 10 column. And there we are, right? 15 plus 6 is what? It's 21. Well, there's your 1, and you drop the 10 column. 21 plus 6 is 27. Well, there's your 7. Drop the 10 column. 27 plus 6 is going to be 33, and boom, we're right back to the 3. Yeah, see how that works? So you got to figure out, you know, what's it adding by? Is it adding by 4, 2, 6, 8? And once each star, no matter where you click it, and what's funny, you're gonna find these stars repeat. One of them will add by 2, one of them will add by 4, one of them will add by, because this one's adding by 2. Let's see, it's anyway, here's another example. Okay, this is, I don't know if this is any easier. It's probably more confusing, but this again shows like, oh, and if you reverse the direction, like this is the very same star. Like let's go from 0 to 4. It's an add by 4 pattern. I mean, it's a you know, Star of Solomon. And you add another 4 and you get an 8. Add another 4, you get a 12. Okay, but look if we reverse the direction. What is it from 2 to 8? That's an add by 6 pattern. So 2 plus 6 is 8. 8 plus 6 is 14. 14 plus 6 is 20. 20 plus 6 is 26. And there's your 6. See how just by reversing the direction changes the math that the shape is doing. Also, if we go in the pentagon formation and change the direction, like if we take the 0 to the 8, this is obviously an add by 8 pattern. If we go to the 0 to the 2, this is an add by 2 pattern. 0 plus 2. 0 plus 2 is 2. 2 plus 2 is what? 4. 4 plus 2 is, yes. 6 plus 2 is 8. If we go the other direction, 0 plus 8 is 8. 8 plus 8 is 16. 16 plus 8 is 24. 24 plus 8 is 32. 32 plus 8 is 40. Drop the 10 column, you have the 0. See how that works? It's pretty cool. But what I wanted to talk about really is how the first 60 digits of the Fibonacci sequence are creating prime numbers. Okay. I think a lot of you mathematicians are familiar with this Maltese cross, and how that if you just do a number sequence and make a 24 spoked wheel, so this is like 1 through 24, but then we jump up here to 25, 26, 27, 28, and just keep going, and you get all the way around here to 48, and you jump up here to 49, 50, 51, and you get all the way around here to 72, and you jump up here to 73, 74, 70, and you just do a 24 wheel. The primes, these are, everything that's circled here are prime numbers, and they tend to align themselves, and even the ones that are not circled, those are semi-primes. 55, 35, you know, this is 5 and 11, this is 5 and 7, 7 and 5 is 35, you know, 5 and 11 is 55. It's either a prime or a semi-prime that falls on these lines. Well, since I'm working, now this is known, this isn't my discovery, I just decided to draw it out just to confirm it. It looks pretty cool though, huh? So I decided to draw out an upside down, sorry about that, 60 wheel, and I didn't bother to color it in or anything. But so now I started with 1, and I did 60 digits like the Fibonacci sequence we're working with, and when you get to 60 right here, you jump up to the next line and it's 61, then 62. Then 63, and go all the way around till you hit 120 and jump up. This is 121, 122, and you get all the way up for another 60. You're going to have 180, which is covered up by that arrow, and jump up to 181. Okay, so I did it, and look, these are, everything in highlighted is a prime number. These are prime numbers. Yeah, 11. 71, 131, I don't know if you can see them, 19, 79, 139, 199, 239. Then this is a this is semi-prime. It does the same thing. This is me. I just did this morning. And so that's what I you know, we were looking at that one chart, and you know, I realized that, wait a minute, all I did was break this up like that, in 2s and 3s, but 2 is a prime and 3 is a prime. So that gave me the idea to look at the primes in the Fibonacci in the 60 wheel, and look at this. Isn't that cool? And I also wanted to point out something else though. The first thing we looked at, which is like this icosagon and icosagram. I've got them both laid out here, the icosagram and the icosagon. It falls on these digits, 0, 2, 8, 4, 4. Guess what? Those are even digits, aren't they? Look at the digits in between. 1, 1, 3, 5, 3, 1, odds. This is another function. Remember, this was the every 9 spiral that actually created this. It's this spiral right here. It is the every 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 4 is adding together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 4. 4 plus 4 is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your 8. And it does that for 3 revolutions until it lands back in the same space that it started, and then it starts over again. And remember, in the last video we talked about it's actually doing math back and forth too. 8 plus 0 is 8, 0 plus 8 is 8, 8 plus 8 is 16, 8 plus 6 is 14, 6 plus 4 is 10, 4 plus 0 is 4, 0 plus 4 is 4, 4 plus 4 is going to be 8. It's pretty cool. And so so this is actually the algorithm, the every 9 for 3 revolutions, which creates, and it's, look what it's doing. It's culling out and separating the evens from the odds. I didn't even notice that before. And I wanted to share that with you before we got any farther. I says, wow, is this and actually, if you look at every place where these are touching each other, matter of fact, if you, I'm gonna have to do some more drawings, because I can already tell, like if we went from the 8 to the 0 to the 8. Well, let's go right next to it to the 7 to the 1 to the 9. 7, 1, 9. Is that a prime number? It probably is. 71 is a prime number. 19 is a prime number. I bet every place where these odd numbers are, 11's a prime number. 91's a prime number. 57 is a prime number. 93 is not a prime number. It's divisible by 3. And I think 19, but I'm not sure. So I'm going to say, based on how intentionally this wheel has been created, 77 is a product of 7 and 11. So this would be a semi-prime. 37 is a prime number. 15 is a semi-prime. It's a combination of 5 and 3. 17 is definitely a prime number. 53 is a prime number. 19 is a prime number. I think 99 would be a semi-prime. Yeah, because it's divisible by 3 and 33, which are both primes. You see what I'm getting at here? 57, back to a prime number, or 75 actually, because we're going this direction. It probably works whether you go this direction or this direction. 51 one way, 15 the other, 73 one way, 37, 33 and 33. And it's probably going to work whether you jump back and forth. I think this every 9 sequence is separating the even integers from the odd integers. It's also giving us the foundation to create prime numbers and semi-primes. That's all I wanted to share in this video, really. Here, they're a little clear. And I found this other, I like this one too. It's like, how about put this little guy there? Isn't that cool? Or, here, I got a better one. Oh, this is it right here. Okay, I love it. Because these numbers seem to love each other. They are using, I don't know how many of you are familiar with sympathetic vibratory physics, but they are actually working together to create the geometric shapes that we know create the platonic solids, which we know create the world. It's like, these are probably think of them as proportions. Think of them as hertz. Think of them as vibrations per second, interacting mathematically in so many different directions. Some of you might wonder about that thing I shared in the first video. I like that. That's pretty cool. I'm gonna make it into a t-shirt. So yeah, if you want to support this channel, I guess this is how we do it. I don't know. I would like to be wearing these numbers on my back. So I'm gonna make these into t-shirts because I want to wear them. I've got it around here, the Kabbalah. I'm not Jewish, but I read all. I've read up on all the world religions, and here we go. And oh, here for all the hang glider pilots out there, let's do this one, man. The Dog Mountain Free Air Force. Here you go. Ah! Oh, okay. Only pilots know what I'm talking about. I like the peace symbol too. Yeah, I'm a little crazy, but you know. People leave me alone. Oh, Aleister Crowley would like this one. Put a little flower in the middle of it. Anyway, some of you would think about that thing I said about the seventh and how it's using contraction and expansion. I think I should really quickly show you why I came to that conclusion. It's not simply hypothetical. I'm looking for the drawing right now. Here it is. I first found it in the. I first found it when I did the 24 wheel. Okay, that this is actually the 24 wheel. We'll get into the 24 wheel in the next video. It's in base 9, by the way, not base 10. It's using expansion via contraction to expand itself. If you take this plus this plus this and move it to the outer wheel, it's a 2. 1 plus 1 is 2. This plus this plus this, move it to the outer, it's a 4. This plus this, move it to the outer wheel, it's a 6. Okay? And you keep doing that, and you have recreated the proportions of the first wheel in another wheel, even though they're using different numbers. They're doing the exact same math in all the geometric shapes that we're talking about. Okay? Yeah. And so then you go, and then, you know, it moves right on up. 6 plus 1 plus 7 is 14. 4 plus the 1 is the 5. I should say in base 9, instead of dropping the 10 column, you actually either subtract 9 or you bring the digits together, which either way works. So if I add all these together, we get 14. 6 plus 1 plus 7 is 14. And then 1 plus 4 is 5. And it just continues out to infinity. And it creates these spokes, okay? Like the spokes of a bicycle. And this is how we're looking at quantum physics, folks, and how it's putting itself together. Spokes of a bicycle, you can go up to a bicycle and put your finger through the spokes and no damage done. But look at this. It's using multiplication to create spin. In the sideways adverse way, 5 times 2 is 1. 5 times 2 is 10, which is 1. 1 times 2 is 2. 2 times 2 is 4. See, the same starting point that is using contraction to expand itself, and then contracts to expand itself, and contracts to expand itself. That's the principle I discovered here that I applied to the 7th, which I think is creating the flower of life. Okay, we're using contraction to initiate expansion. And you might think, well, what does that have to do with the 60 wheel? Well, look at, folks, the 60 wheel is doing exactly the same thing. This is the 60 wheel now, 0, 1, 1, 2, 3, 5, 8. This is 60 digits now. The last digit of the first 60 Fibonacci numbers. And look at this, 3 plus 5 plus 8 is 16. Drop the 10, and you got your 6. 0 plus 6 plus 6 is 12. There's your 2 right there. Drop the 10 column. 2 plus 2 plus 4 is 8. There it is. It's doing exactly the same thing as the 24 wheel in base 9, but it's doing it in base 10. And look at this. It's doing the sideways multiplication. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Drop the 10 column. There's your 2. 32 times 2 is 64, and there's your 4 right there. So think of it as through contraction and expansion, it's creating spokes. And through multiplication in a sideways pattern, it's creating rotation. So now, let's say the wheel is spinning, and this is happening so quickly. Let's say the wheel is spinning, thousands of miles per hour, so fast you can't even see it spin. Now when you try to stick your finger through the bicycle wheel, it's going to take your finger off. It's practically a solid object. And that's what this is. All of this. It's moving so fast, according to this blueprint. It's moving so fast that appears to be solid. The bicycle spokes are spinning so fastly, new word, I cannot put my hand through it. Welcome to our world. Okay, I wanted to, I'm going to put this on a t-shirt. I think it's really cool. Although someone might take a shot at you. They think it's a bullseye. But, okay. I guess that's all. If you like this, hit the like button. Don't forget to subscribe if you want to see more of these videos. And if you want to support what I'm doing, I guess I do have enough material to write a book, my own book. But you know what's going to happen if I write a book? And I'm going to give shout outs to the books that I've read that have helped me on my path as I go. But what happens if I write a book is someone like me will read the book and then it'll be like, wow, that's cool. And I'll kind of add it to my bag, and then that book will end up on my shelf and collect dust. If I put this on t-shirts and hoodies, we'll wear it. And moms, dads, you can have your kids do math on your back. You can have, if this was on your back, you could be teaching them math, 8 plus 0, and that I can just imagine your children tracing this on your back. And that'd be pretty special. 6 plus 4 is 0. 10. 4 plus 0 is 4. 0 plus 4 is 4. 4 plus 4 is 8. Yeah, I could totally see it. That'd be fun. So, same way with all of these. But I'll try to make... I know a lot of you're much better artists than I am. I'm doing the best I can because I think it'd be cool. And then when you wear your clothes out and you give it to a thrift store, you know, then someone else finds it at the thrift store and thinks, hey, that's a cool design. And pretty soon they're looking at this. And I have come to the opinion that the Jewish mystics were correct in their conclusions that our world is being created by the 10 Sephiroth, which they define as living beings that embody the numerals 1 through 10. That's what they decided. And this is alive. And they are creating these shapes. And this is creating our world. So I'm going to roll with that because it certainly seems to be the case. And I think the best way to spread this is new, I think. I haven't been online very much, but as I've tried to search for this online, I haven't been able to find it. So I'm not technologically savvy, and I'm not a mathematician, but I have been entrusted with this particular paradigm to share with you. So, and I think it'd be cool if I walk into a thrift store someday and see this. That would be cool. All right. Take care. Peace out.